Okay, tasks, programs, routines, and tags. On the CompactLogix organization and program scan. Hint, program scan is almost identical to that of RSLogix 500.
I was about to ask that.
Organization. CompactLogix controller's memory is organized by using tasks, programs, routines, and tags. Unlike the PLC, the SLIC, and MicroLogix, the Logix 5000 controller is a multitasking controller, and it can process multiple tasks, programs, and routines concurrently. And that slide, boys and girls, is dead wrong. It does it so quickly that it appears that it is doing it simultaneously or concurrently, but in fact it is not. And a little bit deeper into this slideshow presentation, you'll see what I mean. Main program must be scheduled from the main task configuration dialog. Main routine must be scheduled from the main program configuration dialog. And any subsequent routines are scheduled by using program control instruction jump to subroutine or JSR. Okay, unfortunately, I don't think I can blow this up. Yeah, I can't. Can you guys see that? Kind of, sort of. You sit in the front row, Matthew. You cheat. I'm talking to the guys in the back. Okay, so you notice that we have tasks. The main task, which that icon right there, can't see it very well, but it's 3 or 4 little dots with an arrow that looks like it's spinning in a circle. That tells you that it is a continuous task, runs all time. Under the main task is the main program. And under that program are parameters and local tags. If you remember last week, I said never, ever, ever, ever create a local or a program tag unless you are specifically told to do so. That is where they would show up as under you, if it were a program tag. Notice we got this nifty little doodad here called controller tags, and look where all my tags are. Okay. Also under main program is the main routine, which is the one that will be processed under that task by default. If I should need to have another routine, I can just add it. Okay. And let's throw a no off in here. I just verified my controller, and I don't know why you guys can see that, but it says, warning, blah, 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 routine cannot be reached by the main routine, blah, 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 program, main program. That means that there is no jump or JSR in my main routine to call my subroutine. Okay, that's all that's telling me. So if I go back to my main routine and Just handy little drop down menu. Let me, I can't zoom that. I just handy little drop down. Pick which routine that I want to jump to. And there's dialog box. It's re-verified. No longer have any warnings or errors because now it can get to my subroutine. So, task, under the task, you have the program, under the program, you have routine, or routines, depending upon which one you're talking about. The main routine is always automatically scheduled, and then any subsequent subroutines you have to put in jump instruction. Okay. Organization. I don't know how well you guys can see that, so I want to zoom in a little bit here. Notice we have task 1. That's actually task 2, 3, 4, until you get to task 32. You can have 32 individual tasks in your controller. Okay. There are 3 different types, which we'll talk about here in a little bit, but basically you have, well, we already talked about them last week, didn't we? May have the continuous, periodic, and event. Those are the 3 types of tasks. If, no, you do not have to have a continuous task, but if you have a continuous task, there can be only one. You can have as many periodic tasks and event tasks as you want, up to a maximum total of 32. Okay. And then you have configuration data, status, full handler, watchdog. Anybody know what a watchdog is? Matthew?
I believe the watchdog has to do with the monitoring the how the status of the controller, like if there's any errors or something.
And that would be the fault handler.
I think it monitors the inputs, outputs.
Good guess, incorrect.
Normally use an actual
Monitors program execution.
Monitors program execution. It knows that the program should take X amount of time to execute, and if it gets stuck on something for whatever reason, and it takes longer than the watchdog will allow it to, it throws an error.
Oh.
There is a watchdog timer that you can set, and if program execution takes longer than that, then it throws an error, but it does set automatically based off calculation. Okay.
I take it for each task, the watchdog has the same amount of time unless programmed, or?
No. It's based on the size of the program. If you have a task that only has a couple of lines of code in it, doesn't take near as long to process as one that you have, a couple of thousand lines of code in.
Okay.
Matthew?
So basically what the watchdog will do is it'll calculate based on how big the application, your program is, it knows
Your
that
task, not
Your
program.
task.
it calculates how long that task should take long based on how big that task is.
And automatically sets the watchdog for a little bit longer than that. And like 125% of that time. To give it a little bit of wiggle room, if you will. You can go in and manually set the watchdog timer though, if you want to. But since it's going to figure it out for you, why bother? It's a step you don't have to take. No, I just lied to you. It's not maximum 32, it's maximum of 1,000 different tasks.
What happens when you try to run more than one continuous task?
It won't let you.
Just how it's.
If you try and enter more than one continuous task, it won't let you do it. It says you can only have one, and
Would a machine like this be capable of it, and that we just don't have that as a standard, or that's just the nature of the technology?
it's the way that the controller is designed.
Okay.
It will not let you run more than one continuous. Because continuous runs all the time. So if you are doing something all the time, when do you have time to do something else?
So,
You know, yeah, you can probably walk and chew gum at the same time, but you can't walk to China and swim a marathon at the same time.
if you have the one continuous task, how many other different types can you have along with it? As long as it's not another continuous.
1,000. I lied when I said 32.
I heard that one.
Okay, so in each task, you have up to 1,000 programs. Each program contains a main routine, does not have to, contain fault routine and or other routines, subroutines. And each one of those programs can have its own local tags and parameters. When you create a new project, that's what your controller organizer looks like. Okay. And then over here, your project, you have the main task, main program, local tags, main routine, and then some subroutine that you've added. Okay. So it starts like that, and you can do whatever you want over here. This particular project required 2 periodic tasks. Periodic task number 1, see the little clock symbol. I don't know how well you guys can see that. There's a little clock symbol there. That tells you it's periodic. Okay. And then periodic task number 2, same thing. It's got the little clock icon. So the types of tasks, like I said earlier, continuous, periodic, and event. Logix 5000 controller lets you use multiple tasks to schedule and prioritize execution of your programs. Multitasking allocates the processing time of the controller among the different operations in your application. The controller executes only one task at a time. How can they be multitasking when it only executes one at a time? That just doesn't jive. Okay. One task can interrupt the execution of another task and take control. If you have multiple tasks, you have to assign them priority. Okay. In any given task, multiple programs can be used, however, only one program executes at a time, so. It does everything one at a time. It just does it really fast. It looks like it's multitasking. Default project provides a single continuous task for all your logic. This is sufficient for many applications, but some may require more than one task. For those applications, Logix 5000 processor provides periodic and event tasks. The way that it works, continuous task runs in the background. CPU time that is not allocated to other operations, periodic event, etc., is used to run programs in the continuous task. Continuous task runs all the time. When it has completed the scan, starts over. Okay. Project does not require a continuous task, but if it is used, there can be only one. Okay. Know it, live it, love it, all that. Only one continuous task. Periodic task runs at a specified period. When the time for the periodic task expires, the following occurs. The task interrupts any lower priority task. So I said you have to assign priority to all of your additional tasks. Okay. Much like when you do a subroutine, it takes whatever is in the controller's memory, pushes it onto the stack, jumps into the periodic task, runs it one time, goes back to where it left off, pops the storage data off the stack, puts it back in the controller's memory, picks up where it left off. Okay. Very, very, very similar to subroutine. The period is configurable from 0.1 milliseconds all the way to 2,000 seconds. Okay. The default, however, is 10 milliseconds. The event task runs when triggered by a digital input, a new sample of analog data, certain motion instructions, a consumed tag, or an event instruction. There's an actual event instruction in these controllers. Okay. Just like periodic, it interrupts any lower priority task, and one time returns control where the previous task left off. Okay, so the whole lower priority thing, that's a little confusing for some people because the lower the number on the priority, the higher priority it is. So a lower priority task is going to have a higher priority number. You know, priority 1, most important thing. Okay, priority 10, it's down there with. Okay. So technically 1 is a lower number, but it's higher priority. The controller operating system is a preemptive multitasking system that complies with IEC 1131-3. The system provides the following. Programs to read the data and logic, routines to encapsulate executable code that is written in one programming language. The other thing, whenever you create a routine, you have to choose whether it is ladder, by far the most common, function block, second most common, structured text, or sequential function chart. Those are the 4 types. Each program contains the following. Local tags, only when you're instructed to. Parameters, main executable routine, other routines, and optional full routine. Okay. Other routines and default routine are all optional. The only one that you need, must have, is the main. Routine is a set of logic instructions in one programming language, such as ladder. Routines provide the executable code for the project in a controller, and a routine is like a program file or subroutine in PLC or SLIC. It's all in PLC and SLIC, MicroLogix even. It's called your user program. In 5000, it's routine. Same thing, different name. Available languages per IEC 1131-3, ladder, structured text, sequential function, chart, function block. Again, ladder is by far the most common, function block is number 2. For whatever reason, Rockwell decided that some of the functions that you can use in Logix 500 on a SLIC or MicroLogix, specifically the scale instruction, would not be available in ladder on 5000. Why, I don't know. But if you need to do any scaling of analog devices, from 0 to 100% or, 20 degrees to 1000 degrees, and whatever your scale is, you have to put that in the subroutine. It has to be in function block or one of the other two, which nobody uses. So what do you say? It has to be in function block. And then you have to do the jump subroutine in your main routine to call the scale. Okay. One of the things that took me quite a while to figure out when I first started using 5000 is like, where the hell's the scale instruction? And until I found it, I had to write my own scale instructions manually, which can be done, simple formula, but pain in the butt. Example ladder diagram. Does that or does that not look like Logix 500? Looks a whole bunch like it, doesn't it? The one thing you'll notice is that you have different, you don't have input colon 0/0 and output colon 1/0 or whatever.
Is that 0.0 or am I looking at that wrong?
That is 0.0, yes.
Okay.
Reason why is my dent is a double integer. That's what the dent is.
Ah.
And a double integer is made up of 32 individual bits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on, which is 1, 2, 4, 8, 16, 32, 64 for weight. Makes it easier to convert from decimal to binary. Okay. But since everything is made up of bits, if you're using anything except a bool, you can address the individual bits that make up the int, the dent, or whatever, individually. Okay.
Would it be far more easier or common to do it that way, addressing the individual bits, or?
It depends on what you're trying to do. If you want just an awful one, bool works fine. If you need to have a whole bunch of the same type of off and on, then rather than creating a whole bunch of bools, you just create a dent, int, whatever you need, and then individually address the bits.
Okay.
So it just depends what you're trying to do. But what you got to remember, like we said last week, if you are creating a bool, one bit 0 is the only one that's available. The controller allocates 32 bits of memory. Okay, so if you have a whole bunch of pools in your program, then you just used up a whole bunch of controller memory that you didn't need to, because you can do one of the other data types and just individually address the bits in it. Okay. Make sense?
Yeah, should we keep it a note to conserve memory, or does it not matter?
For the purposes of this class, it doesn't matter.
Okay.
We're not going to do anything that's going to even remotely come close to using up control memory.
Alrighty then.
Example function block, simple add instruction. Add instructions are available in ladder. But it's going to take whatever is in my dent, in this case the value happens to be 0. I'm going to add 200 to it. Notice that it's just a straight value of 200. And then it goes into the destination, which is my timer preset. Okay. Obviously, that instruction has not executed yet because the value of my timer preset is 0.0.
Little number next to the dest is the preset?
Yep.
Okay.
That's the actual value of this tag.
Okay.
That is the actual value of this tag, and that is the actual value of that input. It is not the tag, it is just a straight 200.
Oh. Huh.
Actually, that would not be a 0.0, because that would tell you that it is a real, and all timer presets are integer values. There is no decimal portion. That is medically incorrect. Oh, that's something else too. Whenever you're talking about timers, in 500 you can select your time base. 0.001, 0.1, 1.0. Yeah. In 5000, they're all 0.001. Always.
Really?
Yeah. Time base is always millisecond in 5000. Cannot change it.
Oh.
Structured text. You could probably figure that out.
I need to take a picture of it.
Well,
Yeah, take a picture of it and try to solve it.
Yeah, go ahead. These PowerPoints are linked on the
Yeah, I could, oh, shoot.
Canvas page. Yeah, whatever the hell A is, 14 minus the month divided by 12. Whatever Y is the year, plus 4800 minus A, which was 14 minus the month divided by 12. M equals month plus 12 times A minus 3. I have no idea what they're trying to calculate there, but you can kind of follow along. It's not terribly dissimilar from like a Python or JSON type syntax.
A little bit, needed it.
Tags. For Logix 5000 controller, you use a tag, which is an alphanumeric name. It must start with an alpha character. A, B, C, D, as opposed to numeric. The only special character that is allowed is an underscore. Logix 5000 controllers, there is no fixed numeric format like in MicroLogix, SLIC, or PLC. N70, F81, C50, that sort of thing. They don't exist. However, since you can make your tags whatever you want, as long as you follow the rules, i.e. must start with an alpha character. There's nothing in the world that prevents you, and I have done it, from creating your tags B3, T4, C5, R6, N7, F8, just like you have in Slick or MicroLogix.
And so what you can add those, so it just doesn't come with those tags by default.
Right. You also have to tell it that B3 is bool. T4 is timer, C5 is counter, R6 is control, N7 is integer, and F8 is real or float.
Do you have to do that every time you, what's it? Oh, crap, there's no words, it's the same. Oh, goodness gracious, hold on. Okay, so do you have to do that every time you try and create a new project or?
You have to create the tags to go with it, yeah.
Okay.
By definition, the tag has no max length of what you can name it, correct? I mean, I would assume there's at some point, but
256 character limit, I think.
nothing.
Nothing you're going to run into under normal circumstances, yeah. Pretty sure it's 255, but I can't swear to it. Well, you know, we can look it up if you want to. I've never run into that problem, so. Tag name itself identifies the data. Tag lets you do the following: organize your data to mirror your machinery or process, document your application as you develop it. That's the neat thing about 5000 is it is self-documenting. So if you need a start push button, you call it start push button. If you need a fault reset switch, you call it fault reset switch. Okay? So you can easily see, whenever you're looking at your logic, that in order to get conveyor 1 to turn on, you have to have the emergency stop. You have to have the stop, push button probably. And then the start push button that will allow your conveyor 1 to energize, and then that of course will latch your start push button so you can let go of it. Okay, but you don't have to worry about, you know, is input :0/0 the e-stop or the start button, or, you know, what is it? So
We just put in a,
and then, of course, you have produced and consumed. A lot of people say that produced and consumed are the same because they must be used together. You can't have one without the other. But they perform different functions, so they can't be the same. Okay? They are like yin and yang to each other. You know, you cannot have one without the other, but they are different. Produced tag is one that is producing data for the consumer to utilize or consume in the matching consumed tag. The data type defines the type of data that the tag stores. And each tag must have a data type assigned with it. The data type might be a bit, which is a bool, double integer, which is dent, integer, which is int, floating point value, which is real, timer, counter, string, and so forth. There are hundreds of different data types that are available. Some of them are specific to motion. Some of them are specific to, you know, that, whatever they are. Very specialized functions that we're not going to get into in this class. All we're going to concern ourselves with is bool, cent or short integer, int or regular integer, dent, which is double integer, real, floating point, timer, counter, and maybe string. Structure, a data type that is a combination of other data types is called a structure. Structure is formatted to create a unique data type that matches a specific need. Timer. You have timer preset, that is a dent. You have timer accumulated value, that's a dent. You have timer enable, that's a bool. Timer timing is a bool. Timer done, bool. Okay, so you have 2 dents and 3 bools to make up the one data type of timer. Okay, that makes the timer data type a structure. Use other elements to create a structure that will stand on its own merit. Now within a structure, each individual data type is called a member. We are going to really shortly create our own user-defined data types. And when you're doing that, it tells you to add members because that's what each individual unit is called. Like tags, the members have a name and a data type. So preset, accumulated, timer timing, so forth. And those are dents and bools. Logix 5000 controller contains a set of predefined structures or data types for use with specific instructions, such as timers, counters, function blocks, and so forth. You can create your own structures called user-defined data types or UDT. A whole lot easier to say UDT for most people anyway. When you create a tag, you define it as either a controller tag, which is a global, or a local tag, which is for a specific program. Logix 5000 controller lets you divide your application into multiple programs, each with its own data. There is no need to manage conflicting local tag names between programs, which makes it much easier to reuse both code and tag names in multiple programs. Again, unless you are specifically instructed not to always create controller scope tags. And the problem with program scope tags is you cannot use them anywhere else. So if you have a stop push button in your program, and it is a program level tag, you need to use the same stop button again in some other program, you can't. Okay. Also, if you want to send that data to another controller somewhere or to an OIT or whatever, data historian, it must be controller level or it will not go across the network. Tags. Let's discuss the following example. The ones that are in gray here are automatically defined when you add IO to your rack. Okay. My bool there is a Boolean data type. Take a bit, on or off.
Boolean.
Boolean, yeah. Do you remember from your high school days, Boolean algebra? A plus B equals C?
That's a long time ago.
Can I ask a stupid question?
Are we on a tangent now?
No, it is related to this. I was just curious. With the Java programming, you were able to put notes in the code that don't mess with anything. It's just for anyone else who follows and wants to learn more. Is that possible with this?
Yeah, that's why you put run comments and any necessary descriptors on tags that you create.
It has to be in the form of a tag.
Every data type has to be in the form of a tag. But there are ways to put notes in it to explain things.
Alright.
My dent, see the data type there is a dent or double integer. There's also a plus sign next to the tag my dent. You click on that and you can expand it out. That's where you get the my dent .0, .1, .2, .3 individual bits that make up that double integer. It'll go all the way from .0 to .31. My timer, data type there is timer. You click on the plus button, it'll expand out into preset, accumulated, enable, timer timing, timer enable, or sorry, timer done. Okay. Since enable, timer timing, and done are bools, they will show up as data type bool under my timer. The preset, the accumulated value will show up as data type dent. There will also be plus signs next to those that you can expand them out and you can get to my timer.pre, period 0, period 1, and so on.
So this is the 5,000 equivalent of the data files tab?
Essentially, yes. So, there it is. I'll create my timer. Notice that it defaulted to the dent data type. And it's going here, tell it that it's a timer.
You know, you have to type the whole thing, you can just type TIM.
Well, some of those, you have to type several characters. Some of you only got to type one because it's the only type that starts with that letter.
Ah, that's really neat, that's still really neat.
But notice timer.pre is a dent, ACC is a dent, and then the other three are bools. Well, I can expand that out and get to my timer PRE .0, .1, .2. Okay, so I was talking about.
Okay, makes sense.
You notice that the PRE is data type dent, and then .0, .1, and so on are all data type bool. So they can only be off or on. Nick?
Little strange question here, but I forget exactly what description does. Is it like a comment where you can describe what it does, or does it actually affect?
That is a descriptor.
Mm-hmm.
You know, my bool doesn't really tell you a whole bunch. It just tells you that that's mine and it's a bool.
Mm-hmm.
Well, maybe my bool is the widget warmer on indicator. That would go under the descriptor.
Mm-hmm. It does, the descriptors actually affect the actual, okay, good. That'd be very
So
strange.
it's just a descriptor.
Okay.
So on descriptors, you can make it alphanumeric as well as the aliases.
Yeah, a descriptor can be anything.
Descriptor can, it's like a comment thing where you know, have you ever done JavaScript?
1 CR, 2 CR, you know, widget warmer, on indicator, whatever you want to call it. So my timer, if I go here to my descriptor, the description of my timer is the widget warmer timer.
Widget gets cold.
Yes.
What's the difference between an integer and single integer?
It's not single, it's short.
Short, okay.
Short integer is only 8 bits long. Integer is 16. double integer is 32.
Mhm.
Notice the things are grouped in element groups, just like in 500 is also. All your timers and counters are in timers and counters. All your comparators are under compare. All your math instructions are under compute math. So. Okay, so I put in timer, my timer, and it says that my timer is the widget warmer timer. Okay. Which, by the way, the bit separator or the bit delimiter in 5000 is a period. It is not a slash like it is in 500. But the done bit off of my timer inherited the same descriptor as my timer, and it's saying that it's the widget warmer timer. Okay? There is absolutely nothing that says that I can't call this the widget warmer timer. Then I don't need the descriptor.
It would be easier to just put a timer with it.
Yeah, if that is the widget warmer timer, then why not just call it widget warmer timer?
I guess you could use the descriptions for other things too.
Yeah. The descriptors are there
Yeah.
for your use, but they're definitely not required. That's the beauty of doing tag-based programming, is it is self-documenting. Okay, so that is actually the last slide in this show.